This session will be recorded, and by the end of this webinar, I will be sending you the recorded session. And in addition, at the end of this session, I will send you a link to fill it in order to receive a certificate of participation for this webinar. Today, our topic or our subject that we are going to work with is how Arduino could help us in order to integrate STEAM projects at our school. But before starting with Arduino, I'd like to clarify this concept of STEAM and how the integration should be proceeded in order to reach a successful result. By definition, integrating STEAM at the school means that during the year or by the end of the year, we are expecting from students to create technological projects using STEAM tools and STEAM concept in order to solve a problem that we are facing in our real life, or to reimagine or to reinvent solutions already existing, but with an enhanced way. So we will be expecting those students to develop those projects, and we as teachers, we should be supportive for that, and we should be ready in order to reach this output. And to be ready to reach this output, you as teachers, you should have a solid background about how to proceed with. So mainly when we talk STEAM, it's not about the ICT teacher who is concerned about. It's about all the teachers with the different disciplines at school, starting by science, math, biology, art, languages, and of course, ICT teacher. And we believe that the ICT teacher will play a major role in this because he is supposed to have all the let's say background in coding and in electronics and in microcontrollers and robotics and so on. But beside those skills, we have to know that students needs more let's say skills in math, in science, in biology, in art, in languages, and it's not the role of only the role of the ICT teacher to provide and to deliver all those concepts. That's why it's very important to keep in mind, you as ICT teachers, that we are supposed to coordinate with the different disciplines in order to reach the final output. I'll show you maybe a product that I have designed using like a 3D printer with Arduino. It's like a meter using a laser beam in order to measure a specific distance. So me as an ICT teacher, I master the science of the Arduino and how to code, but I'm not sure if I'm ready to design, such a shape in order to create it or to print it on a 3D printer. This is first. Second, I'm not sure that actually how to explain for students the idea of the beam and how to calculate the speed of the wave and other concept. That's why there is a part of this project that should be done with the ICT teacher, maybe 80%, and there is another part which is that should be done with the art teacher, with the languages teacher, with the science teacher, and maybe with the math. Why not? So they will be participating with those projects. And in order to establish a clear roadmap for integrating STEAM projects, it's very clear. First, you as ICT teachers, you should be aware about all those technologies in terms of Arduino, microbit, 3D design, robotics, coding, and other. And the roadmap consists on, let's say, building a table for each grade. What are the proposed projects that could be done using the technology? And across or over the year, you will be start manipulating those projects and developing those projects with the students. And be aware also that this could not be done during the computer science period. It's not enough as a time frame. What you need is to give or to dedicate more time for that, and then if you are let's say and then if you are planning for developing projects, all the teachers should be participating to those projects, and each one will know that for this grade we will be having those projects, and for this grade we will be having those projects, and so on. So after this short introduction, I will move directly to start with the Arduino as a ultimate solution for the STEAM projects. And from my own experience, I can conclude that teaching or understanding the concept of Arduino is divided into like 4 layers. The first layer will be understanding why Arduino is popular as much, and why students should understand or should practice microcontrollers or Arduino, or even for the lower grades microbit. So this is the first layer as a general knowledge or as general information. And here, be aware, I will open a bracket to say that while doing an assessment to make sure that your students capture or did understand well those technologies, so we believe that you must do a written assessment, a theoretical assessment, to make sure that all students got the idea of the general knowledge. Because, and trust me, it's not really important or it's not healthy, I will say, to practice Arduino and to create projects. But if we want to make sure that or if we want to ask students for some questions regarding IoT or microcontrollers and how it will help, so this will be really a tough mission. And if students will not be able to answer, you mean that you did not succeed with your mission. The second layer, and here I will try to send you, I took a note about to make a short video in order to explain you the first layer, which is understanding with all the questions and answers that might be supporting this first layer. For the teachers who are using our curriculum 01 for this year, you will be having access to our digital platform, and on this digital platform you will have all the resources regarding the teacher guide, lesson plan, answer key, extra resources, and many other just there is a question. No, I will send it by mail at the end of this session. By the end of this session, I will send you a link for a Google form. You will fill it in order to receive the certificate of participation. And for all who are present here, they will receive later on this video. Okay, so I was saying that what is the first layer, which is understanding the concept of the microcontroller and its direct link to IoT, machine learning, artificial intelligence, and other. The second layer is understanding the hardware. And this is a crucial part that makes you, let's say, understand and be fluent with the hardware that you are dealing with. You must, without any doubt, with a click, let's say, understand all the hardware you need, how it functions, and then how to build a circuit later on. The second layer is the layer of coding. And this layer of coding, could be made over two parts or two sections or two paths, which are block coding, like Scratch, using Tinkercad, or the C++ coding using the Arduino program. And both will lead to an output where students can try, or virtually, or by hardware, if the system or if the circuit they build is working properly. Okay? And here, students will be invited, starting from grade 7, to start what we call the simulation on the screen, to create some simple circuits, and later on to create those circuits by building them on a hardware, and later to upload the C++ code to check if everything is working correctly. And the layer 5, the layer 4 is this link with what we call STEAM. And when we talk STEAM, we talk about product design, we talk about imagination, we talk about creativity, and we talk about 3D design in order to extend or to create something which is really similar to the real world. And here there is many ideas. Later on, we will be conducting a specific training on the 3D printer in terms of technicality and in terms of inspiration and innovation, in order to create, let's say, solution for products. And I can give you a hint. For example, one of the products or projects that we are creating right now is by using the servo motor that you all know, and technically this servo motor that can turn like 180 degrees from 0 to 90 to 180 degrees to the left or to the right. Okay, so we are implementing, and soon you will have it, a product designed on a 3D printer where I can master the like a thermometer, and I will divide it into, let's say, 4 sections, and my product will be turning to indicate according to the temperature and the humidity sensor. If it's too hot, it's hot, it's cold, it's a good weather, or it's cold. So imagine like students are doing this weather station, and even later we can use the rain station or the rain sensor. I'll be showing you in case you don't have it. So you will have this rain sensor, where also for the weather station you can integrate it in order to check if it's raining or not. And if we have a small house, and after washing our clothes and putting them out to dry, so I can program my servo motor in order to close or to open the mechanical construction where I put my clothes to dry. بالانجلش I don't know what I didn't do the exercise, بس أنا بعرف بالعربي منشر الغسيل. So for those who understand Arabic. So and even you can translate it if you have it. So so ideas will come to you in a clear way, step by step. And if you don't have the 3D printer, for those who are using our curriculum, and this is a very important message for you to be contacting us, we can provide you with samples of those items in terms of exploring them with your students. So I want to say again, we are not teaching Arduino just for the love of Arduino. We are not teaching Arduino just because we are asked to teach Arduino. Actually, no, we are teaching our students Arduino because it's very important, and it's in direct link with the future, with tomorrow, to understand more what does it mean, the word of Internet of Things or IoT, what does it mean for machine learning, what does it mean for AI, and how those structures in Arduino can help us in collecting data and in storing data in order to analyze them later on. So I believe that now it's clear for you that those 4 layers for you as teachers, once they are clear enough for you, you can transmit those ideas and those technologies and those projects in order to do the best for you. I will as I said, I will be sending you later on the tutorial or the video recorded for the layer 1. During the weekend, I'll try to finalize it and to send it to you. I'll move to my second layer, which is the hardware, before moving to the software. So I'll be trying to open my, just 1 second to check where is my file. All right. Okay. Okay. So as microcontrollers, I'll be sharing my screen. Please let me know if it's okay or not. So just confirm me if you can see my screen right now or not. Can you see my screen, please?
Yes, we can see it.
All right, great, great. Thank you, thank you. Thank you very much. So, as I said before, the word of microcontrollers mainly it's obvious that now all students, all schools are searching for this implementation, and the major two microcontrollers that are dominating the market, the educational market, are the Arduino and the microbit. And we all know that the microbit is dedicated for lower grades, since it's more easy for integration, but the Arduino is for higher grades, I mean for grade 7 and up till grade 12, where students are asked to have like a prerequisite or background in electronics, in coding in a professional way. And we can see that with Arduino, we can do beginners, starter, and advanced projects in Arduino to make solutions and to solve problems that we are dealing with in real life. So here I'll be taking like 2 examples of how to manage or how to reinvent a parking gate using the ultrasonic sensor with the servo motor, even with the LCD, in order to manage the free places for this parking. We can create a station to irrigate plants when the soil is dry, and to give us warning for that. And we can create like a distance meter using the ultrasonic sensor. We can create a humidity and a temperature station in order to measure the temperature and the humidity, in order to take the accurate action for that. So what are the hardware that we are dealing with, and which software that we will be working with? So from now, I believe that we have in this meeting like 60 participants, and I'm quite sure that there is participants who already explored with me or alone those skills. So let us be patient, and thank you for your understanding to make all the community be aligned with the same concept. So what I'm focusing on in this slide is the Arduino board. And for those who don't know well the Arduino board, it's an electronic board, as simple. You have the cable in order to power this Arduino, and in order to upload the program once done on the computer. We have a connector for a 9-volt battery, and we have 2 rows of pins that are up and down, and we will be exploring them later on. You can see here that you have pin number 0, 1, 2, 3, 4, 5 till 13. You have the ground. You have A1, A0, A1, A5. You have the 5-volt, the ground. So all those pins will be discussed and will be manipulated later on. The next element that I have to make students understand is the Arduino breadboard. And this breadboard, it's a simple tool which is the it is compared to the socket wire. So that's why here its role is simple, as you can see on the screen. It's to give us the ability to join many components at the same time in order to program them alone. Because without the breadboard, it's like impossible to do this job. I remind you that by the end of this session, in like 30 minutes, I'll be sending you a Google form to fill it in order to send you a certificate of participation, and later on to send you the recording session and the video I promised to deliver. The third hardware that I'm dealing with is the LED, the LED, that will help us to illuminate them for a specific reason. And you can see that for each LED, you have two legs. There is one shorter and the one which is longer. So this is in physics. Students will understand it from the physics teacher, which is the cathode and the anode. And of course, while creating the circuit, we will be exploring them in a clear way. Of course, we have to know that there is a element, a hardware called the resistor, and the role of this resistor is to protect the LED or any other electronic components from burning, so it will reduce the flow of electricity. So you can find resistors like 220 ohm, 1 kilo ohm, 10 kilo ohm, and so on. The third element, or the fourth element, I don't know, it's 1, 2, 3, 4. The fifth element is the motor. And here you can find two kinds of motors. You have the motor, the servo motor, and you have the DC motor. And the difference between both is very clear, that for the DC motor, like this one, it's not, it's good, but you cannot control the position of the rotation. There is no encoder sensor inside. What you have is a motor that can turn forward and backward, and then you can define the speed of this. And practically, this servo motor, this DC motor is ideal for like wheels, for a car, for something that is turning and turning, like a ventilator. So it's like this. The servo motor, it's totally different. As I said before, I will do the reminder. It's a small motor where it can turn from 0 to 180, and you can position the rotation to a specific angle as clear. And you can see here that you have 3 cables. You have the brown, the red, and the yellow. Sometimes the brown is black and the yellow is white. Keep in mind that the red output, the red cable is connected to the 5 volt. The yellow or the white is connected to the ground, and the brown or the black is connected to the signal pin. Also, later on, you will be discovering more how the connection will be made. But this is to keep in mind that we have 2 kinds of motors. You have the servo motor and you have the DC motor. I'll move to the buzzer, which is the piezo that is connected in order to reproduce sound. Then after, we move to some sensors, which are the ultrasonic sensor that measures distance. We have for like the temperature and the humidity sensor, which is very practical for steam projects, like the servo motor, of course, and like the ultrasonic sensor. And by the way, here, an idea for a steam project using Arduino is that you can create on your 3D printer, and this is what we are going to do and to deliver for our clients, is like 2 trash bins where we place in the middle an ultrasonic sensor, all right, for each trash bin. And when I approach a specific object to throw, you will order the trash bin to open, even the first one if it is considered for plastic, and the other one if it is considered for paper to be recycled. So and for the temperature and the humidity sensor, of course, also you can have many ideas for projects. And one of the projects I told you about is to create the weather station according to the hardware. You have to know, for those who are not aware of, that for Arduino, there is a set of like 37 sensors, and you can see that all sensors, maybe it's not really clear here, I will make it a little bit bigger, but all sensors have 3 pins. And remember always that every time the logic is the same. I mean, you have 1 pin for the 5 volt, 1 pin for the ground, and 1 pin for the signal. And it's for you to create the scenario of coding in order to measure temperature, light, sound, infrared, gas, and other options. So, of course, if I want to continue with the sensors, the list will be long. So we will not forget the sensor to measure the level of water. I'm trying to search. So this sensor that is to measure the sensor of water, the sensor for rain, the sensor for, as I said, the humidity and temperature. So many sensors are available in order to get inspired and to create projects for STEAM. Now I'll be moving to the second part, the third layer, which is the coding. And for coding, as I said before, you have 2 options. And this is very critical for you to make it clear. So as I said, we have the Arduino software, which is a free software actually, and there you can write your code using the C++. But here, please be aware, for Arduino, students are not asked to memorize the Arduino code, like in Python or in Small Basic. Please do not commit this error by asking them to memorize the code. Why? Because simply in the Arduino software, there is a section for examples where almost all the ideas for the hardware are implemented in order to modify them and to apply them for your project. So what is asked from your students is simply to make them understand the way we program Arduino with C++. Then the students will go and open an example, and they will be able to modify it. So that's why keep in mind this idea. But to tell you the truth, that for grade 7, 8, 9, it's very important to start with Arduino. And if you are using our curriculum 01, for sure you noticed that we started with 7, 8, 9 by implementing simple concepts of Arduino using Tinkercad, by using the coding, the block coding, which is very simple. And at the same time, for higher grades 10, 11, 12, we move to C++ with the physical construction. So don't wait till grade 10, 11, 12 to start Arduino. Take action now and do your job in a great way, and start, because students will be happy and will be motivated in order to have this implementation. So that's why for lower grades and even for higher grades, if you feel like it will be a little bit hard for them to start directly with C++, so it's better for you to start with Tinkercad. What is Tinkercad? Actually, Tinkercad, it's a platform. It's a platform where students will create their own circuits virtually, will code it simply, and will make the simulation to check if everything is okay. And then I'll be showing you how to move from this simulation to the translation of the code block to the C++, and how to copy and upload them on a real circuit. It's really a synchronized way, a simple way in order to reach this point. So I'll be moving to let me check. Just okay. By the way, if you are user for 01 for this year, you have to know that beginning of this month, all the accounts are closed in order to start a new academic year. That's why you have to make sure to reactivate your account in order to have access again to our platform 01.education. So all you have to do is to log in. If your account is not active, he will be asking you to reactivate it, and we will be doing it after checking the status of the school. So here, if I go to, I'm on my Tinkercad platform. If I go to create and I move down to the circuit, so a new project will be designed. You can change the name here, and on your left, you can see all the hardware that you might need, from basic to all. So you will have additional, let's say, additional hardware. So I'll keep on basic. And the first option or the first manipulation I'll be doing is to take a board of Arduino. It's clear here for you that we have the digital pin 0, 1, 2, 3, 4, 5 till 13, your ground, GND. You have two grounds here. You have the 5 volt, you have the 3.5 volt, and the A0 to A5 analog pin. For sure, we will not have enough time to explore them all, but in the near future, we will be animating more webinars regarding Arduino with ideas for STEAM project. So for sure, you will be invited for that. So once I move my Arduino board, I click on code, automatically you will see that there is a sample code written for you. So if you click on start simulation, you can see that you have this LED is blinking, which is the built-in LED. So this LED, it has the address 13. I mean, if I stop the simulation, I take a LED and I connect my shorter leg, which is the cathode, to the ground, and the anode, which is the longer leg, to 13. Okay, and I run again my program. So look here, the LED, both LEDs will start blinking simply because this LED, it has the same address of 13. And if I move and I take it, I will have to stop the simulation. I move and I put it on the 11. Okay, and I run my simulation. You will see that the LED 13, the LED connected to 11 will not blink as this one, because now we moved, or we change the address. So what I have to do with the code, simply I have to delete all this, and from the output, set pin number 11 to high. From the control, I will go for wait 1 second, and I will duplicate and set low for 1 second. And when I click on the start simulation, you can see now that the LED is blinking in a correct way. So you see that the programming for this, it's very simple. It's like Scratch. So students will not face any problem for that. Now, if I want to try it on a hardware, I mean, if I'll take a hardware and I will create my circuit physically, how I can translate my project, look how it's simple. I click on code. I open here the list of text and block, and you can see automatically that the code is generated under C++. So students here will understand that they will have like a setup loop, a setup procedure, and a loop procedure. In the setup procedure, I am defining that the pin 11 is considered as output. It could be an input for the sensors. And in the procedure loop, I'm reading that the digital write 11, it's on mode high, I have to wait 1 second, and then it's in mode low, and then I have to wait 1 second. And in such a way, what I'll be doing here is I'm blinking my LED. So what I'll be doing in order to take them to the Arduino, all I have to do is I select, I copy, I launch my my Arduino program. Let me check, where is my Arduino? Here it is. So I launch my Arduino program. It's launching. Okay. And then I will paste my code here. And if I have my board, now it's not available, but if I had my board connected, I will make the upload, and you will see the LED on my breadboard blinking, my Arduino board blinking. So back to the Arduino, the Tinkercad Arduino interface. I will close all this. I stopped my simulation. So now that you know how the flow of process is very clear and very simple, from Tinkercad, how I do my block programming, how I can convert the block programming to C++ programming, and then to upload them on the real board. So I believe that you can start in a safe way teaching Arduino. Again, for those who are manipulating or who are using our curriculum, I believe that they see the flow, how it is clear, how the chapters are clear with their what we call the teacher guide or lesson plan, in order to give you all the details that you need for. If I want to continue, I can say that I can add a breadboard. I will do it in 5 minutes. Okay, I will delete this one and this one. So I will take my breadboard. I will place one LED. I will place another LED. And since in this internal section, the pins of the breadboard are connected vertically, as you can see, and here they are connected horizontally. So what I can do, I can take my ground from here. I connect it here. So now all this row is connected to the ground. So I can take a wire from here till here, a wire from here till here, and then the half of the circuit is done. It needs to be continued. So I will take the pin 7 to connect it here, and the pin 4 also. And this is my circuit done. I have 2 LEDs, the first one on the 7 and the second one on the 4. So I can go for my code. I can create here my blocks. So I can modify for 7, 7, and as simple, I will duplicate all, and then I can go for let's say 4 and 4. I believe that you notice how the programming is very simple. Start simulation. So you can see that the 2 LEDs are blinking respectively, the one after the other. If you want to make them blink together, all you have to do is to move the blocks in this way. And this is the start simulation. And now the two blocks are blinking together. The aim of this webinar is to have a memory refresh after this vacation, and for the new one in this education sector to have an idea about the 4 layers that are segmented for for Arduino to reach a successful project in STEAM. For sure, it will not be the end. Later on, we will be providing you with advanced or intermediate projects in order to continue this journey. Now, to respect the time allocated for this webinar, which is 1 hour, I'll be obliged to stop, and I'll be sharing with you the link for the Google form. It's on the chat, so you can click and you can start directly filling the information in order to receive the certificate of participation, the recorded session, the video for the understanding the first layer for Arduino, and to receive always updates. Tomorrow and after, I believe tomorrow we have another webinar. I don't have in mind the title, but it should be interesting. And next week, also Tuesday and Wednesday, we will have two additional webinars. So hope you will be joining. I hope that this webinar was useful for you, for those who has previous information. So it will be like a refresh memory. And for the new one, hopefully it was a successful event, a successful webinar. So please go ahead, fill the Google form, and we will give you tomorrow another meeting so till now I have few of you that filled the Google form. So please do fill the form in order to receive all what I have mentioned before. Again, thank you for your attendance, and hope tomorrow. If you have any specific question, please do not hesitate to send it to me on my WhatsApp. I will send it to you, 96133806333.